right. The clock is running. Participants.
Oh, nice. It kept the background. Perfect.
Perfect.
Hello, here we go. Wonderful.
Spotlight. There we go. All right, Judy, you have the floor.
So thank you very much. It's absolutely wonderful and good. That's better. Seth, are we going to begin? Do we have no, we don't have everybody. We're going to wait for everyone to join, aren't we?
Yeah, we've got 9 people in now. Hi, everybody. We've got 3 minutes left till the top of the hour, whatever meridian you happen to be on, and then maybe we can give it another minute or so after.
Yeah, I think so. I must say, even though I sent out a reminder this morning to register for the webinar, some people, they'll go to the invitation on the hour and then they still want to register. So, but I can see that everybody's coming in. This is really great. This is some marvelous familiar names, and so yes, I'd like to welcome Fred Bruvala. Fred, we haven't seen you for way too long. Dr. Afriki has joined us as well. We've met him many years ago. He's with us on the African continent. And we also have Cassie Zielinski, and she's joined us from Georgia. And Rudo, fantastic, wonderful to see you here. Rudo is with the Virginia Space Grant Consortium.
Oh,
and
right.
Yeah, absolutely. So that's great. I can also see that we are joined by some of our students who participated in our space STEM programs from the African continent, across the African continent. And yeah, this would be mission 3 for them. So yeah, and so they've have quite some great experience. And then Daniel Lee, welcome from New Jersey. And Daniel, you're going to come up in the conversation this evening. So that's fantastic to see you around. And I can see that Bianca has also joined us as a panelist. That's wonderful. Seth, if it's okay, would you like me to bring up a slide where I just have the agenda?
Oh, certainly. Yeah.
Okay, great. Thank you. Please, I need permission.
Oh boy. All right, just a second.
Okay, let's see. There we go. Fantastic, thank you. Wonderful. Great. There we are. Well, welcome everybody to our Rocket and Payload Challenge. And this is an information session for everybody. This is actually, it's the first real information session that we've had regarding this, this particular challenge. It's a partnership between bluShift Aerospace and MaxIQ. And on the screen, I just have some bullet points of what we're going to be covering over the next hour, maybe even 90 minutes, but we're hoping that it's not going to stretch that long. The why and the what of the Rocket Challenge, the hardware to be used. Bjarke is going to share with us his developments, the experts to be engaged, the rollout plan, topics to be covered in workshops, the curriculum that's going to be made available, as well as the deadlines. And I would really like to introduce my collaborators, Seth Lockman from bluShift Aerospace. Seth, thank you very, very much for setting up everything. For everybody who's joined us, I've always admired the way that Seth facilitates these webinars. And so, Seth, thank you very, very, very much. You're a very, very valuable member of the team.
Thank you so much.
Not only for bluShift Aerospace, but for us as well. Cody Harris is also assisting me here on the virtual stage. And Cody looks after all of our social media. He's actually building this program itself. So Cody he's joined us. He's busy studying mechanical and aerospace engineering at the moment. So he's joined us as an intern, but he does way more as an intern than any intern has ever done in any of the businesses that we've run. And so Cody Rest, thank you very, very much.
Thank you for having me.
For your participation, of course.
Absolutely.
And then we're also joined by Bjarke Gottfredson, who is one of our fellow shareholders and founders of MaxIQ. Bjarke is also the co-founder with me originally in X in a Box, which is the business that actually started all of this off, and also happens to be my husband. So Seth is going to be interviewing me tomorrow for a video, and one of the questions he's going to be asking me is where I met Bjarke. So we're going to save it till then. I'm not going to share that right now in this session, but wait for that movie, and then you'll all find out how I met Bjarke. And so yeah, what I'd like to do is we're going to be monitoring the questions in the Q&A. We'll be monitoring those throughout the entire session. Some of them, if it's really does relate to the topic at hand, then we'll certainly take that question at the time. Otherwise, I think what we could do is let's maybe have a few question and answer sessions. I wouldn't like to say we keep them all for the end, because maybe we want to just change the pace a little bit. So perhaps every 15 or 20 minutes we go to questions and then we come back and that kind of thing. So let me just start off by saying the why and the what of the Rocket Challenge. Yeah, Bjarke and I have been looking for a launch partner since 2014. And we've found it very, very, very difficult. We have done a number of satellite missions. We've done 2 missions to the International Space Station. And when we were introduced to bluShift Aerospace by the main spacecraft consortium, by Terry from the main spacecraft consortium, for us it was just this was the Goldilocks solution for us. They are a new startup business, highly innovative, and that resonates very well with us because we are very high-paced and we develop very fast and we move very fast. Also, the thing is that they're looking at small volumes of CubeSats, and also because of their location on the coast of Maine, they can reach a polar orbit. They can launch to a polar orbit, which is really, really important to us and to students all over the world, because a polar orbit serves everyone across the entire planet. So we felt that this was really an ideal solution. And so we've been in discussions with bluShift Aerospace for a number of months. And when they decided that they were going to start putting down their plans, they had a very successful launch in January, test launch in January. And after that, when they started putting down their plans to say, now we're going to go suborbital, those dates we're going to go orbital, etc., we felt what we're going to do is we're going to come to the party. So as MaxIQ, what we did is we made sure that we gave them a purchase order that was large enough to encourage them to keep their business going. Yeah, so what we've done is we've reserved space, excuse the pun, on every single bluShift launch. And now what we're going to do is we're going to fill up those spaces. And instead of just having it as a normal launch, we are looking at converting everything to a challenge so that we can have workshops, we can engage everybody, students can participate and experiment and win and fail and get things right and make mistakes, and we build this thing all together as we help bluShift Aerospace get to orbit. It's very, very, very important that they do for us and for the not only for the education community, but also for the research and development community. So that's really the why and the what of the Rocket Challenge. Seth, are there any questions that maybe we could look at now before I hand over to Bianca?
At the moment, the chat is clear. I did notice bluShift CEO Sasha Derry in the audience.
Oh,
if
great.
Add him to the panel, or I can just reclaim the host thing real quick and add him to the panel as well.
Yeah, I think, absolutely. Please do.
Okay. Hey, we can still screen share, right on. Okay.
Wow. Okay. I'm going to stop sharing anyway, because I think Bianca may need to share.
Okay.
Terrific. Sasha, I'm very, very pleased you could make it. At one stage, we thought you weren't going to be able to make. Hello. Sasha, so you've had some adventures of late. Securing your launch site on the coast of Maine. So yeah, you're looking very, very optimistic and positive. So something tells me it's all going very well.
Yeah, I've had a lot of coffee this morning. Yeah, it's out in the news now that we're looking to possibly develop a launch site off of Washington County, Maine, which is specifically a town called Jonesport. It's still premature to say it's a sure thing, and we're looking for some backup options. But we're absolutely sure we're going to find a launch site off the coast of Maine to provide easy access to polar orbits down the road for our CubeSat customers. So we're very excited about it. It's a lot of work, and I think still making rockets is harder, but finding a launch site is a very close second.
Yeah, absolutely. I can imagine. Yeah, so what I'd like to do is, Bianca, please may I hand over to you?
Of course. Actually, we do have one question real quick from, I'm sorry, I'm probably going to butcher the pronunciation here, but Sayan or Shane Flad asks, is polar orbit particularly helpful for examining the effects of global warming?
Sayan, yes, great. Sayan is one of the students participating from the African continent. In fact, like Bianca and me, he's in South Africa. And Sayan, definitely polar orbit certainly would be. What is really great is that when you have a polar orbit and you're orbiting around the poles, what you do, and with the Earth spinning on its axis, you're able to cover the entire planet. And so there we will really be able to see the impact of climate change, global warming, natural disasters. What you'll have is you'll have a very good pass twice a day over any particular location. So you would be able to track, for example, a wildfire. You would be able to track the size of that, perhaps some flooding that's occurring, pollution. I know that in your team, when you had a look at the Sustainable Development Goals and how that linked to space and space projects, you were very concerned about industrial pollution and how do we bring everybody to account for the mess that they're making. Absolutely, it's the ideal orbit for that. So yeah, great question. Thank you very much. Mr. Bianca, please, may I hand over to you?
Thank you. So I'm in a little dilemma here. I can't get my camera to work, but I hope the sound is fine. So I'm doing a presentation anyhow. So you have to look at this beautiful poster picture of me from back when I was slimmer. So that's probably also all right. Thank you very much, Judy. Thank you very much, Seth, and the rest of you guys. It's great. I'm going to talk a little bit about our plans for what we are going to launch with the bluShift rocket here. So I need to get permission to share. So whoever is the host, please allow me to do that. I think that happened there, and then yeah, why not do it like this thing here? So you should now be able to see my page here. Let me just do it full screen. Can I just, Judy, give a thumbs up that you can see my presentation? Okay, cool. So I call it the vertebral column system here. There's a replacement of the old XKR1. So I know we have a lot of viewers here. So some of you are familiar with our old technology. We call that kit the XKR7. What we're coming up with here is a replacement of the XKR7. And I'm going to kind of like share a little bit about how that's going to look like. So this solution we are putting together here is something that fits into a 3U CubeSat. So we're using the 3U CubeSat form factor to send what I call collective satellites into space. So what that means is that we don't deploy the satellites. Each payload is packed into this 3U. So each slice is a payload, and it goes into this 3U satellite, and that goes on board the rockets. And when the rockets hopefully get recovered, we get the payload back, and each institution who participating gets their payload back. So the big difference is that if it was a satellite, it'll be deployed and you will not get it back. But it's different here. So the CubeSat, just again, I just want to spend a second on it because maybe not everybody is familiar with it. But it's a form factor. It's probably the most famous satellite form factor. And in reality, it's just a cube is just 10 by 10 by 10 centimeter, which for most of you guys probably a 4 by 4 by 4 inches. But it is space, so we keep us in metric here. A 3U is just 3 of those cubes next to each other, so that's 30 centimeter. And it is the most prolific satellite format out there. It's basically the 3U format. So we are building 3U containers, if I can put it that way, where we can then slot in a payload. And as you can see here, the payload is like a slice. It's like approximately a centimeter thick. So it's 10 by 10 centimeter, a centimeter thick. And then you can probably get the mass, but I'm going to elaborate a little bit about that, talking about this analogy I use to a vertebral column. So if you can imagine that the vertebra is actually the core of your payload. And to that vertebra, you have ribs, and in this case here, you don't, but you have sensors and other payload details that's connected to this vertebra. The vertebra has a core, and it's connected to a spine, and it communicates via this spine to a central unit in this 3U. And that central unit is making sure that everybody are behaving on this little bus. So if you are spending too much power, you get shut off. If you want to send data to the ground, we can't have 30 antennas on board here. So there'll be one radio sending data down and so on. This system here have 2 spines. You will see how that works. And interesting enough, if each of these payload is 9mm thick, we will have 33 vertebrae, and that's the same as in the human body. So that just turned out hunky-dory. This is the vertebra. So it's a core, and I have a number of different details on it. So you can see here that we have the ESP32. So that's the same CPU, MCU that you have in the kits we are sending out these days, the SDG kits. So for you who's not familiar with it, it's a 240 megahertz, 32 bits dual core RISC processor. There's also a low core and a low power processor on board. It also do Wi-Fi. It also do Bluetooth 4.2, and it do Bluetooth low energy, so BLE. Obviously, those things you're not going to necessarily use in space, but we use the same core in everywhere now, and therefore it's just easier this way, because then if you want to learn to develop in it, you can program this thing here in Python, in MicroPython. You can program it in Arduino. You can program it in various other technologies. So it's a kind of like easy to access core. It's quite prolific. We have put extra RAM in it, and the reason for that is we put a camera on it, and with this extra RAM we can capture, at least 2 megabytes of pictures at a time. So we can do, we can take a video film down, and there's a lot of software already for this ESP core. It's like TensorFlow from Google. You can do machine learning stuff, so you can do image recognition, like facial recognition and that kind of stuff. And there's a lot of that software that's ready-made out there that you can play with. Then the vertebra communicates over the spine using a CAN bus. And the nice thing about this ESP32 is that it have CAN built into it. We just have to put a transceiver on to kind of like make sure the levels are correct. So therefore we have this CAN transceiver to kind of like communicate. CAN, for you who are not familiar with it, that's the bus that most cars are using. So when a car communicate, the different devices on the car communicate with each other, they use CAN. And they've also been used in space quite a lot. It's like the favorite bus technology out there. So we are going to use that as the way we communicate to the host over the spine. We have the camera connection. It's a MIPI CSI camera connection. So that allows you to put a camera on. It can be a 2 megapixel camera all the way up to 5 megapixel. They have like different kind of cameras with like night vision and things like that. And then we put a lower radio on it. So there's a 433 megahertz lower radio. So we're going away from all kind of different radios. This is the same as a 70 centimeter band. So a lot of institutions already have access to use that frequency, because it's the frequency used in ham radio and that kind of stuff. And another thing is, of course, you have a minimal disturbance also when you use that frequency, especially like over US, in Europe, and in Africa. 433 is ISM frequencies, like 915 is in the US. So here it's free to use for everyone. But hopefully when we fly in space, we have less problem with that. We've been using this radio forever. So no new technology here from our side. So this is a lower radio. And we've been putting on a balloon. So we flew a balloon a number of years ago, and we've been able to reach over 200 miles from a ground station to a balloon using that specific frequency and that specific radio with a a normal dual-pole antenna. This core here, that fits within our normal system. So if you're familiar with our normal chips, then we have, you can see it fits within 3 chips, similar to if you have 3 chips next to each other. So Judy is holding up a bluShift chip there. And at the end, this gray rectangle and the PCB, the slicer PCB is what symbolizes the spine. You will see it just now, but you can see there's a spine on both sides, and that means that each our chip is 32 millimeters, so we are still 96 millimeter in both the one and other directions. So that gives us within our 10 centimeters, so we fit inside the CubeSat format. We haven't yet figured out where we're going to put the Vertebral, but we're probably going to put it to the one side that allows you to have 2x3 chips on the side. We're basically doing a prototype board that allows you to do your own projects if you want to do that, and then slide it into the Vertebral. The Vertebral for now have to be this one, so we can control power usage and communicate and all that kind of stuff. But we will allow anybody to program it themselves. We're going to do some initial software, and then we hope that we can get into a collaboration with whoever participates here that want to participate in doing the software. We gonna do that using GitHub, and then hopefully everybody like to kick in with the different ideas that can run on this core here. So at the end of this Vertebral, we have this modified PCI Express connector. So you can see up in the top right corner there is a PCI card, and that have this what's called a 1-lane connector, so that 36 pin. What we've done with ours is that we're taking 4x2 pins out in the middle, and that allows us to flip the Vertebral. So we can put it in upside down, and it still works. And that's because the 14 pin you can see on the one side are the same as the 14 pin on the other side, just in the opposite direction, if that makes sense. So when you flip it around, it still works. And that gives a redundancy when we plug it in the one end. So if it's slightly loose or the rocket are shaking this thing here, then hopefully there is enough that it holds together. We don't need all the pins, which is also the reason why we do that. And of course, this is not a PCI Express standard of any kind. We are just using the form factor of the PCI that lowers the cost both on the board and the connector, simply because there's so many PCI connectors out there. So when we build this solution here, it's we can reduce the cost quite a lot. I modified this presentation a little here. Discussed it with one of our partners, William Edmondson, and so I just want to add. Here's another picture of this connector here. And that's, of course, how it looks on a Vertebral. On the spine, it has a connector that looks like this thing here that's sitting there. And that's, there's one there, but if you can imagine, there's a whole row of these next to each other. That's actually the spine. Then here's an example of the spine. So on the bottom, you can see the 30 centimeter long spine. In this one here, I only populated the top and the bottom and the middle one, but when we're going to fly, we're going to populate all of them. And then we're also going to offer a test spine. So that's the one with the 4 connectors on, and that's so institutions say, listen, I actually want to test the whole setup. I want to test this control units, and what we're going to do is that we're going to use the same Vertebral as a control unit. Initially, we're not going to, for the first flight, develop anything special other than the software. And we are, and therefore, if institutions want to play with it, they can just get 2 vertebra and then load the control software into the one. Obviously, also when you have 2 spines and each side have redundancy, well, with 2 spines you get 4 times redundancy, and it's simply just so it actually gives more stability than anything else. I'm not sure I'm going to stick to having a spine on both sides, and the reason for that is I'm also playing with using the same technology to stack solutions on top of each other. I want to talk a little bit about the connectivity here. So there's 14 pins on both sides and each end. So the 10 pins are the standard pins that you see on our normal chips. Judy, if you hold up a chip and point at one of the edges, then you know there's 5 pins here, just slightly closer to the camera. You can see there are 5 pins there, and of course there's 5 pins on the other side. Those 10 pins are the same 10 pins we're using in a vertebral connector here. And then we have 2 pins for the CAN, and we have 2 pins that we reserved for I2C controlled power control solution. So that's not implemented now, but we just reserved the pins for it for later. The spines have the 120 ohm resistors that you need for CAN termination. So in none of the vertebra have a termination implemented. It sits on the spine. And then, as I mentioned, the center of control that we put in is just going to be a vertebra that we have made with the software that controls that in Italy. Later on, we're probably going to make a dedicated central control. So if you want to test that, then get another vertebra and then we can test it that way. I also had basically drafting a stacker. So if we take the spine that I mentioned before, it's actually only have power, CAN, and that I2C lines. It doesn't have the other 10 pins going through because they belong to each of the payloads. But if you have your own payload and you have so many sensors, or you want to do something that takes more space, so you can't live with 10 by 10 centimeter, you want to have another layer, then we're basically doing a stacker. And the idea was that I could use the same PCI connector to stack. And if I do that, then it would be those 10 pin that stack, not the CAN and not the power control I2C. So that's the idea. So I'm basically prototyping that to see how that works. But I have a little bit of a design issue with this thing here. So I'm going to figure out if that's going to hold. The idea is maybe making it round, because that allows us to stack 2 layers of chips for inside a model rocket or something like that. And you can see I can possibly move those 2 connectors much closer together, which allow for a smaller diameter, opening it up to more rockets than I have put together here. We have other development going on for this solution. So we're doing a new global navigation satellite system chip. So the old one had like a couple of limitations. So it typically took a very long time to get a satellite acquisition. So this one here have a battery backup. That means that once it's got connection, it holds its connection even if you're disconnected from the rest of the kits, as long as, of course, the battery is still in, but it sits on the back of this unit here. We're doing an external antenna connection. The old one had a chip antenna on board, which gave a very, which was limiting in the signal. It was, of course, much easier to use because the antenna was just sitting on the GPS unit. In this case here, we have a UFL, and it uses the active antenna that sits. So Judy is holding up the old GPS, and underneath her finger, you can see there's a little white bar there. That's actually the antenna. It's called a chip antenna. In the new one here, you're gonna get a proper active GPS antenna that sits with a UFL or IPEX connector, so you can plug it on the outside of the rocket or balloon or whatever you're flying with. We also added external memory so non-volatile external memory, so it can store more almanacs and for longer period of time. And then the new chip we're using is using 2 satellite systems, so it acquires not only from GPS, but also from one of the competing systems. So there's more satellites in the sky to get a signal from. Other than that, we are busy with, and I don't have any drawing on that right now, but we're doing a LiPo battery module. The way that's going to work is that it's a LiPo battery, probably a 14500. So it's a battery that looks like a AAA battery. It's the same size. It's just a LiPo rechargeable, and it's 3.7 volt instead of the 1.5 or 1.2 that the traditional AAA batteries are. And it replaces the old AA dual AA battery solution we had, which was not rechargeable. Yeah, so that's what Judy holding up there. So the new one here will just have a single battery, a LiPo battery, and it will be charged over a USB-C connector. So you can also run the circuit using USB-C instead of the other power solution we have, which is based on a USB-A connector. Then, of course, we still have all the other sensors, so they will survive. We're probably going to upgrade IMU, so we're going to have another 9-degree of freedom IMU, so accelerometer, gyroscope, and magnetometer. But that's I think that's about it. So the big new stuff here is the Vertebral, the new core, if I can call that, which replaced the radio. Oh yeah, and the core also have an SD card on it. So you can store data. You can use that either for store forward, for example, if you collect data that you then store until you get radio connection, and then you download the data when you have radio connection. Or you can, if you recover your payload, you can of course just take the data off the SD card that way. So it have a SD card like that, but it also have a quite powerful core. It's when you turn off everything, so Wi-Fi, Bluetooth, and things like that, and you go into a deep sleep mode, then you only use 10 microamp. So it's not like it using a lot of power. So you can, turn it on every 15 seconds, take some readings, and go back to sleep. Or you can run stuff longer using the low power process on the core. When we fly in a rocket, you can fly the whole thing full speed all the time, because the rocket flight is not that long. So we have to be nervous about the power we're using. And Judy, I think that's it from my side.
Bjarke, fantastic.
Any
thank
questions?
you. There were some questions that I think that we were able to field. There was just Fred Bruweiler wanted to know if we were going to have some kind of an integration manual or a framework. And I said, certainly there is going to be that. I don't know if you want to comment on that, Bjarke.
Yeah, so
maybe William can also come in on that. He is in the audience.
Yeah, so the way we're gonna do it here is that we have a let's call it a payload standards. So depending on how much time that have, what we are aiming at for the first flight is at least to get the Vertebral and the standard connectors flying. So school institution who is just want to have something that try out and fly and kind of like get into space. That is our number one priority. We're also doing this a prototype board, which is 2 by 3 chips in size, so 10 by 6-7 centimeter wide. which have normal 0.1 inch holes and connected to the bus and all that kind of stuff. So you can hand solder a solution together, and of course you can also do your own projects like Fred, you guys have done in Washington before. So no difference there. The software that we developed for this thing here is being open source. It's in GitHub. Everybody will have access to it. I hope that people are gonna help developing this thing here. That's my dream here, and you know, testing it and all that kind of stuff. I'm gonna do a manual way as soon as so what you're seeing here is actually in the prototype production right as we speak. I'm expecting it to come in here on well, it's not been shipped yet, but I expect around the 13th of December I will get it here. And as soon as I figure out if I have to screw it up or not, it is the first prototype, then I'm starting coming out with production of this thing here. And people that want to kind of like be early in on this thing here, I'm happy to send you know, prototypes and things like that. And then in the first instance, I'm just doing 5 of these. We have a fairly quick turnaround time with our prototyping facilities, so I'm not too nervous if I have to change anything. There's not a lot new on this Vertebral, meaning there's not like a lot that I haven't actually used before. So both the radio, the only thing that's actually new is a CAN bus, but that is a fairly standard setup. So I hope that works. So that's actually my main concern to get tested. And then I am going to do integration manual and documentation on how it is and all that kind of stuff. I'm probably even going to leave Eagle files. So Eagle is a PCB development solution that's open source, and most of this level of using developing PCBs are using Eagle. So Adafruit and SparkFun and all those are Eagle files. So I'm probably going to leave Eagle files for a lot of this thing here, so people can you know, build their own sensors or whatever they want to in this format here. Yeah, so to try to make a very long answer shorter, yes, there is going to be ICD manual for this project here.
Great, Bjarke, thank you very much. There was another question about have we tested the connector? I answered that myself, and that is that we've been using these connectors since 2016, and they've flown on over 80 student satellites, and also we've had 2 visits to the International Space Station. So they've survived going there and back with both Northrop Grumman as well as SpaceX rockets. So we're not too worried about that. And we've also, there's a number of groups around the world who've conducted high altitude balloon missions, and yeah, and the payloads have survived. So yeah, we're not too concerned about the connector. But if I can just quickly say, sorry, Bjarke, if I can just quickly say, that is also why we're doing this project. What we're doing is we're doing this project to build and test payloads. So nobody who's going to be participating in this challenge is going to be expecting something that's going to be completely out of the box, plug and play, because it's all part of the experience, this learning experience. Sorry, Bjarke, over to you.
Yeah, so there's 2 connectors. So maybe whoever asked are referring to the Vertebral connector, the PCI connector. So we haven't used that before. We haven't tested that. I'm fairly sure that's gonna work fine. One of the things, Judy, if you hold up the XK7 you had before, with the connectors we have already, you can see that the middle chip have 4 connectors, so there's 4 times redundancy. And none of the chips they have less than 2 times redundancy. So when you have like a circuit with all these connectors, you can take like 3 or 4 of them out, half of the one and half of the other, and the project will still run. Thanks, Judy. And the thing is that we have flown on satellites. You know, the Stensat flew with these using the same connectors, no difference. We also had our own high altitude balloon project. Actually, we had a high altitude balloon project where we had 3 payloads running. There was 14 payloads in total, and the parachute didn't open, so it came down with close to terminal velocity. And our 3 projects still ran fine. We had a camera with on a server that broke off, and we have a solar panel that broke off and that kind of stuff. But the project was still running and the camera was still recording and all that kind of stuff. So I'm not too nervous about our normal connector. And I'm not nervous about the PCI connector either. That's quite solid. It has a lot of contact area compared to our small connectors. And as I mentioned, they sit in a 4-time redundancy position. So I'm pretty sure it will work. The other thing is also when we fly rockets, you know, the thing is that as long as it doesn't have to necessarily operate while it's under the hectic G-forces, but only have to operate afterwards, then, you know, it can reboot all the time. So the way we're doing the software is that, hey, if we will have watchdog time and that kind of stuff. So if something goes wrong, it simply just reboots and it runs again. When we have put stuff on the International Space Station, it's been powered off while it flies there for security reasons, and only powered on while it's there. So of course the G-force there is extremely low. It's lower than here on Earth. When we fly on rocket, and especially when we fly with the bluShift, we're probably going to have it on all the time. It's going to take all the D it can, and we're looking forward to see how that works. But that part we're not nervous about. Let's put it that way. Other questions, Judy? You're on mute. Okay.
Yeah, no, sorry. I was struggling to get my mouse to show up. Bjarke, yes, there is another question, but what I'm going to do is I'm going to field it a little bit later.
Okay.
When we move on to the topic. So yeah, nothing more necessarily relating to you, but maybe we'll have some questions a little bit further down the line. So yeah, thank you very much. What I'd like us to cover now is for Cody and I to share with you a little bit of the experts who we're going to be engaging along the way on the project. And so Cody, should I hand over to you?
Yeah, sure. If you want me to start it off.
You've been given the unenviable challenge itself of building this program.
Of building the challenge.
So,
the challenge of building the challenge.
The challenge of building the challenge. So can I hand over to you for
Absolutely,
just a few minutes? Great.
Sure. So I think I'm going to start off, and I'm actually going to kind of touch on something you might have already brought up, but it's the what and the why of the challenge, right? So the first thing that we really were interested in is just expanding the program, right? So right now the program's focused more on the electronics, but for somebody like me, you know, I'm really interested in the rocketry. So it's how can we get students who have a more interest in the rockets, you know, involved in that aspect of this whole program, right? So number one is, you know, to expand the student knowledge and their understanding of, you know, how these things happen, how these things work, different forces that are taken into account. Another reason though is to, you know, add to the experiment. You know, a big part about science is comparing different data. So, you know, the students will receive their initial data when they build the kit on, you know, the ground level in the basic situation. They're going to use the model rockets to gain more data points. And then when they use the bluShift rocket, you know, they'll be able to compare all 3 different sets, which I think will be really awesome. And then to help with that, though, we're bringing in experts from a whole different areas. We have some from education, We have some from our model rocket manufacturers. We'll be able to give instructions on design tips, variables to consider, a whole bunch of stuff like that. And then also engineers who actually work on the real life rockets, hopefully some from bluShift, will be able to come in and give the students a couple of tips or tricks or things to note for when they're building their mini Starless Rogues. Yeah, so I also want to talk about what are we going to be including in the bonus classes, right? So for starters, I want to talk about basic rocketry. Not enough that the students can go home and in their basement build their own rocket, of course, with no chemical formulas or anything too crazy, but like what are the goals? What are the terminology? What are the different type of major systems, whether it's a solid rocket, hybrid rocket, liquid? And then, what, again, like I said, the variables to consider when they're designing there. So, the diameter, the power of the rocket, the weight of their payloads and whatnot. And then when it comes down to it is how are the students going to be making their rockets, right? What kind of model rocket are they going to be using? So we kind of want to leave this open a little bit up to options. So I've been working with a couple different model rocket manufacturers, all extremely knowledgeable experts, and they're great people. They're going to be helping us custom make our own payload sections and everything that can fit the kits. But also we've been finding other resources that, if your students are a little bit more developed or they're up to the challenge, you can go in your own time and kind of come up with your own design. We're encouraging 3D printing, we're encouraging reusable materials. So really, you can use our systems that we put in place, or you can try to figure it out yourself. So we're really encouraging both. But number one, though, we just want students to be actively learning more and more information about the whole industry. So, and then Judy, should I let them know about like what the grand prize is going to be, or how do you feel about that? Should we wait on that?
No, I think Cody, go for it. Yeah.
Well, I'll say this too.
It's a challenge. We need to know.
We need to have a prize, right? There's got to be something.
What is the
champion
prize?
So what I like to do is I like to come up with a whole bunch of criteria and almost like a point system, if you will, where we can almost rank each of the different projects. And I would like to have a couple different place winners. But for the first place, I should say this too. As you know, for this first rocket launch with bluShift, it's going to be a suborbital rocket launch. So it will not be achieving its peak heights. But for the grand winner here, we like to sponsor or basically put your kit onto the full orbital ride. So when bluShift gets it all the way up, your kit's going to go right back on their rocket, and you'll be able to get some more data points. It should be a great experience.
Thank you. Yes, Cody, absolutely. And earlier today, we actually had a session with the group who are being sponsored by Intelsat from the African continent, and they've actually already designed their payloads for CubeSats and are really looking forward to the opportunity to being able to launch them. So yeah, I think everybody's going to be up for the challenge. And Cody, thank you very much for taking us through that.
No problem. I left out one detail though, if you don't mind. I'm sorry. Something else I want to do too is that, hopefully we can inspire a few students to actually pick this up as a hobby, the model rocketry. And what I'm doing is I'm putting together a whole bunch of resources of students who, if they'd like to carry on with that afterwards, after they're doing the MaxIQ program, that, they can join various groups or different forums where they can learn more information, or just a whole bunch of resources. So, it doesn't have to end with the MaxIQ. This isn't the end of their journey. It's the start. It's something that I really want to push out there.
Excellent. Yes, very good points. And yeah, you're collecting these wonderful resources to share with everybody through the program. One of the questions that's come through from Mark is, what are the use cases for suborbital launches and recoverable payloads, etc. That's what we're looking forward to. We're looking forward to the students identifying projects that can be conducted. This is a very low risk environment that they're in. And so what we can do is we can really experiment here. And what we want to do is we want to make sure that we can really broaden the scope. And so anybody has an idea of what they want to look at, what they want to research, we want to be able to accommodate that. In the past, we've been able to accommodate a lot of different experiments. Bianca had shared during his presentation that he's very happy to that he shares the Eagle files for the footprint of the chips. And there certainly are some students. Daniel Lee, I know that you're in and out of the session because you're actually teaching right now, but I do know that some of Daniel's students at Princeton High School, they actually developed their own chip to fly on one of the ThinSat missions. Fred Bruweiler and the team from American University, they also developed their own chip that they could actually interface with the X-in-a-box payloads, etc. So yeah, it's very open. We're not going to be dictating anything. Yes, Bianca.
So I also saw this from Andrew. You know, what is the what's the options here? So what we have done historically is that we've been flying it on a party balloon. So 32, 36 inch party balloon filled with helium. And then we actually have, there's a number of different institutions. There's Cambridge University in the UK, have a kind of like a HAP predictor, so high altitude balloon predictor, that we've been using. And we've been flying with just a party balloon, you know, it's around a meter or something like that in diameter. We've been flying up to 12 kilometers, 36,000 feet and we actually even had a flight that took 9 hours and eventually left us over the ocean on the way to South Pole. But we have, because of the radio and things like that, we've been able to pick up data and reconstruct the flight and all that kind of stuff with the GPS. You can also fly it on a high altitude balloon. Either you conduct one yourself, or there's a lot of institutions where you can buy a space on a high altitude balloon. They simply just have a long string where you tie yourself into that, and then you can get on that. We have been doing a lot of work together with Virginia and Mid-Atlantic Regional Spaceport, MARS, as they call it out there. They have a drone flight station there, so you know, with you know, big time UAV, so they could fly on that. We have projects where they simply just want to use it as a remote environmental monitoring system, so that use the lower radio and that they may be mounted somewhere other than that, you know, like on top of a building on a mountain, or you know, out in a boat on a lake or whatever it is. So there's a lot of different prospects for using this thing here, where you can actually recover it again. One of the other things, of course, is that if it's recoverable, that means that it's not it's as expensive. It's probably one of the reasons why Elon Musk is so upset about making sure he can recover his rockets. There's no difference if you can recover your satellite, that you could reduce the cost, especially when we are in this learning institution here. If we can be in a situation where we can recover our satellites and fly them again, that's always great. And it's especially great if we have had a project and we can kind of like exhibit the results with the satellite that actually flew in space and been there. That always helps. We know that from the project we are running on International Space Station. When we get them back, you know, there's you know, a number of different sensors that we can spread out to each of the students, or you know, have it in a exhibition, you know, a hall of fame of some sort, and say this was actually in space, that flew up there, it gathered data and things like that. So a lot of different use cases that is more accessible than if it was a fully deployed satellite. Let me put it that way. But again, I want to, you know, support what Judy says. We look forward to a ton of other use cases for this thing here. And especially one of the reasons why we have it like in this 3U form factor and a bus like this thing here is because if we have other projects, then if somebody offers another flight, we we worked with the Department of Education last year. There was a CubeSat challenge there for the CTE schools, and one of their goals was actually to fly on a hot air balloon. So one of those New Mexico hot air events and flying that. So yeah, I think there's it's just the imagination that stops us from imagining where we can fly a group of satellites like this. Judy?
Great, Bjarke, yes, thank you very much. What I'd like to do now is that I'd like us to go through in terms of what is our rollout plan, what is the plan right now. Originally, when we posed this and we started developing this challenge, we felt that we would like everybody to sign up by the end of December, end of this month. However, that is not that is really not viable. There's a lot going on at the moment. So what we've decided to do is to extend that deadline for signing up to the end of January 2022. So what we're doing is we're extending that deadline to sign up till the end of January. And it also gives Bjarke and William and the rest of the team a lot of time to complete their prototyping of their core, as well as to test it, send it out, have a lot of people start using it, etc. Because we don't want to push that development. It's already happening fast enough, but we don't want to put undue pressure on that. So that is our first deadline, is for everybody to sign up by the end of January 2022. There are a number of schools and universities who are going to be participating who have never, ever seen a single X chip. And when they see it on the screen tonight, it's like, wow, what is that? Is that like some kind of Lego for adults, or, you know, for electronics or whatever it is? So what we're doing is in those, with those institutions and those groups, we've put together a mission 1, and that is using our STEM kit, which relates to the Sustainable Development Goals. And all of those components are going to be reusable. You're going to be able to repurpose those as part of your payload. So what we're going to do is we're going to put together a workshop series, so that what we can do is we can make sure that everybody is introduced, and everybody's at the same point when we start the workshops. So our goal is that what we do is beginning of March, everybody will have received their kits, and also beginning of March, what we will do is we will start a regular fortnightly workshop. A lot of you may ask, or the questions may be posed, yeah, but you know, when are you going to do it, and what time are you going to do it, etc. We do realize that we have people who are going to be participating across the globe. So we're not going to have one time for the workshops. We're probably going to run 2 or 3 workshops in parallel, so that but at different times, so we can accommodate everybody, and we're not inconveniencing the team in Hawaii, the team in California, the team in Japan, etc. So we're certainly going to make sure that we can accommodate everybody with those fortnightly workshops. In between those fortnightly workshops, we'll have a lot of catch-up sessions. I'm sure we're going to have a question that relates to, but what paperwork am I going to need? So we're going to need to bring out an expert on that. Probably it's going to be Mike Miller. Mike Miller is always our go-to guy for those sorts of things. You know, so Mike will do 15 or 20 minutes for us that we'll record for people who can't be there at the time, and then that'll be distributed to everybody. So what we'll have is a little bit like Bjarke's design with a spine and a number of vertebrae. We'll certainly do that. We're going to have the formal workshops every fortnight, every 2 weeks, and then we will have topical, unplanned workshops as required, so we can make sure that we are 100% relevant for everybody participating at every single point of this journey. We'll have a lot of catch-up sessions as well. Perhaps some teams have been writing exams, or they've missed a number of sessions, so we'll have some catch-up sessions for them, etc., to make sure that we can all move together on this trek from the beginning of this challenge through to the end of this challenge. And so I can see here that Kirsten is asking the question, is the March start date for the beginners as well? And Kirsten, I think what we can do is let's have a look at that, because we are going to be in a position to ship those starter kits, those STEM kits before that deadline for March. So we could certainly have that program, that Mission 1 program, during February. So when we start in March, everybody's on the same page. So I really like that. Thank you for pinging me on that one. In general, the way we're looking at it is we would like to make sure that we can cover enough in terms of the model rockets, payload design for the model rockets. How do you design your rocket? What kind of rocket are you going to use, etc., so that during what the US schools would term the spring break, so that's around about April-ish, April, May kind of time of the year, that groups can then start working with their model rockets missions, and learning from those and repeating them, and having some lessons learned, etc., and really optimizing their payloads. And then after that, what it is now we at the point where we're going to be getting ready for our bluShift launch. And so Seth, if you wouldn't mind coming in here, and what are your plans from a bluShift side?
Absolutely. Thank you, Judy. I just want to make sure, I believe Sasha's still on the call. I want to make sure he gets the chance to take the question. I believe he is activating his camera.
Thank you. So the question is, what are our plans for in terms of orbital and or the time frame?
Sasha, I'm terribly sorry for that. It's what we would call in rugby terminology, we would refer to it as a hospital pass. It's when the ball gets passed and you get tackled straight away. So no, what it is that the teams participating in the Rocket Challenge will be conducting their model rocket projects during sort of spring break, April, May sort of time of the year. And then for our suborbital launch, where these payloads are going to be on your suborbital launch, we were just wondering what sort of time frame you're looking at for that. We know it's probably somewhere around late Q3, maybe beginning of Q4, something like that.
Yeah,
I'm sure you've got a better idea.
Yep. Yeah, no, that's exactly it, Judy. Thank you. Yeah, we're targeting, for that 100-kilometer launch, the beta test, for late summer up here to early fall. It's important we want to get qualified all the way up to the Kármán line. And then after that, the following launches will be up to 350 to 400 kilometers up to space. So yeah, that's the time frame. I'll be the first rocket guy to tell you that whenever rocket people promise you things slip. So I don't want to believe it that way, but it's really important for us on multiple fronts to hit it by Q4 in any which case. So yeah, so just in time for the fall semester for most of the folks north of the equator.
Great. Yes, Sasha, that's absolutely fantastic. And yes, we all are aware that sometimes these timelines can move, and as you found in January, sometimes it's because of the weather, and there's absolutely nothing we can do about that.
Yeah,
Sometimes we just have to wait. It's a very, very sensitive game. You have a community to consider where you are launching your rockets. So one can't be too laissez-faire. There you go. Can't be too laissez-faire about it. So yeah. Also, the thing is that we do have a large portion of our participants are in the Northern Hemisphere. So that time of the academic year can also really be a bit rough. So yeah, I think that it with some flexibility there, that's really going to be well accommodated. So thank you very much for that.
Sure. And we are looking forward to you joining our flight. So not you personally, but the MaxIQ devices. So, and the students from around the world. Yeah.
Yeah, absolutely. And the thing is that Sasha, your launch site, being on the coast of Maine, is going to be very accessible for the students in the US actually to attend the launch. And I think that is really going to be something incredible to be able to do that, because there's very few people who have ever been able to attend a launch, never mind actually being able to see their own payload being launched on a rocket. So I think as soon as we have those details, we'd like to share that with everybody. So maybe what they can do is that they can start considering some travel plans when we get closer to the dates. Cody, I was just wondering if you wanted to come in here. I think we have a bullet point for you here in terms of curriculum available.
Sure.
I know you did mention it earlier that you are going to have some materials available, but I'm not sure if you want to expand on that at all.
I mean, I'll touch on it lightly for now. What I will say though is that the internet is a fantastic resource, and that luckily it seems the rocket community in general, from big to model, is very happy to share what they know, share the resources that they have. Furthermore, I will say though that we are including, like I said, our manufacturers do have quite an expertise, at least in the model rocket area, the smaller scale. So either some representatives from the manufacturers or some of their connections will probably bring them in, and they have a whole curriculum that they said that they'll be willing to share with us and maybe update a little bit, or we can make changes to that'll more fit our needs or the needs of our students. I think that's all I want to say on it for now until we can get the complete package put together, just because I don't want to promise there might be something in it that doesn't come out to be, or maybe we'll include some things that I don't mention today, but I'll definitely keep everybody updated. So.
Thank you, Cody. And I think we're having a little bit of a technical situation. We lost Judy on the call. So if everyone can just imagine, hold music for a minute or two here. We're going to straighten this out.
Looks like there might have been a few more questions from folks there in the chat.
Something else I will say too,
Yes.
though, actually, while we're waiting for Judy, is the fact that we are encouraging students to go out on their own though and to research some of these things, right? So like we will provide you more than enough information to do it yourself, but we would like to encourage that your students go out and that they look for the particular goals that they'd like to meet, and they look for the solutions on their own, you know. I think, like I said, that they will be able to do, of course, with all the material we provide, but we're looking for individualism. We're looking for students who are going to go above and beyond, and those are going to be the ones that we select for the orbital launch.
Great, Cody, thank you very much for that. For some reason, somehow I left the meeting, so I'm terribly sorry. I may have left you stranded there, but you didn't seem to miss a step. So when I came back in, everything was perfect. So great, thank you for that. You're very talented. You can tap dance as well as design rocket challenges. It's very important for a young man to be multi-talented.
You hear that, Sasha? No, Sasha.
Tap dancing, I hear, is
Yes.
really difficult in 0G. So I don't know. That's what I hear.
Absolutely. So yeah, I think let's go to some questions. Certainly, let's start fielding some questions. And Sasha, yes, thank you very, very much for being able to join us, because I'm sure we've got a number of questions for you, our rocket man. So let's just go here. Seth, I'm not sure if you just want to help me have a look through here.
Yeah, taking a look.
I think because I had to rejoin, I've kind of lost the chats. It's just
Volk
quite
had asked,
interesting.
you want to reach as many schools as possible globally. Oh, Cody, you replied yes. Okay, I'm sorry. Yep.
Yeah, so I think we have a pretty much an open floor. If anyone has questions, now is the time. You can submit them in the chat, or you can raise your hand and we will allow you to talk. The meeting is being recorded so that folks can tune in later in case they weren't able to make it today. Just be advised, if you do talk, it is for posterity. All right, here we go. Jim Volp asks, how are your connections with educational offices of space agencies around the world?
Okay, let me answer that one. Jim, yes, thank you. We have fairly good relationships. And I think that is because from a MaxIQ perspective, the 4 co-founders, we hail from different parts of the world. So let me take, for example, Dr. William Edmondson, who is in the audience this evening. William has been a member of the CubeSat fraternity for many years and has been delivering CubeSat systems engineering programs at undergrad as well as postgrad level. William, I'm doing a shocking job here. I admire William's incredibly, and I feel as if I'm really not introducing him properly. And the thing is that William also has very good relationships with the European Space Agency, as well as a number of African space agencies. Jack Kennedy, one of our 4 co-founders. Jack has been on the board of Virginia Space Flight Authority. When he retires from his current role as a county clerk, one of the county clerks in Virginia, he's probably going to take up a role in Florida in terms of leadership in the space community, and he actually has a degree. He has a master's degree in space law. He's actually an attorney by original qualification, and he's one of the few people who's actually graduated in a master's degree in space law. Then there's Bianca. Bianca and I have absolutely no background in space whatsoever. Bianca's an IT engineer. I'm a chemical engineer. But even through this process, we've been able to build terrific relationships. With the support of the South African Space Agency, we've built incredible relationships with the BRICS member countries. BRICS is the acronym for Brazil, Russia, India, China, South Africa, the little s, tiny little s at the end of that. And so we've been introduced to those agencies as well as a number of others. So yeah, I think we've got great relationships. We've been able to build a fair amount of credibility with a number around the world. So yeah, we're looking to leverage these relationships to support bluShift Aerospace in terms of being able to expand their business globally to sign up payloads. Sasha, I know you have very strong relationships with NASA. If you want to share those,
sure. I mean, NASA is a big organism, so but they have been really instrumental into sort of providing us assistance. I think, we're hardly the only company in, at least in the United States. I think actually there's several companies outside the U.S. have received assistance from NASA to develop space technologies, not just rockets, but well beyond. Probably our closest connections has been around with Marshall Space Flight Center, which has really assisted us in developing our technologies around our hybrid rocket engine, the Marvel engine. So they have definitely been a critical part of development, and they are, I expect will continue to be so. It's a resource that we go knock on the doors whenever we have questions from everything on how to do wiring in more compliant ways, to plumbing, to really, really odd idiosyncrasies about how to make combustion happen just right in these odd little rockets that we're creating. I did see a question from Kirsten Hibbard about whether the payloads will be recoverable. And I wanted to say, yes, that is the intention. It's certainly not the guarantee. We certainly, for Starless Rogue, we are intending for not only the payload section, but the entire rocket, the Marvel engine section, to be reusable. And it's important for us to try to recover everything and reuse it. So, and of course, the most critical of all those are the payloads. Yes. We intend to, we're targeting internally returning the payload back to our customers back on the mainland within an hour. Externally, which is what I'm not doing both right now, but externally, I think it's realistic that we could probably have our payloads, your payload, back to you within 2 hours, unless it's at the bottom of the drink, as they say. But and we'll be recovering a few miles off the coast of Maine. So, and we already have some really interesting ideas on how to bring back the payloads even faster directly to you or your students on the mainland. So keep that in mind when you're thinking about how large energy storage or data storage you want to have on your experiments. That you will want it to be capable of either shutting down once you get to a certain pressure or altitude, or be capable of continuing to capture data right up until it's returned to you.
Great, Sasha, absolutely. Yes, we are planning that they are recoverable. Also, the thing is that we don't only need to consider the payloads that are going to be on the rocket. What we can do is there's a lot of data we can collect in the environment surrounding the launch site, which will be very, very useful for everybody going forward from an environmental impact study, etc. And also, I think maybe relating to one of the conversations I saw in a thread a little bit earlier is the whole thing around the vibration profile of the rocket. The thing is that all of the students are going to have these wonderful IMUs, giving us 9 degrees of freedom. This black one is actually, the reason why it's black is because this is one of the space grade ones that I was using on my high altitude balloon kit that I'm building at the moment. But, this is going to give us 9 degrees of freedom in terms of acceleration, magnetometer, and gyroscope. So it's going to give us pitch, yaw, roll, G-force. So we'll be able to certainly pick up the vibration, and we'll be able to build that profile. So, it's going to be really interesting to see the location of that payload in the payload bay and what that vibration profile looks like. So when we have, these all of these data points, we'll be able to, I think, build a really nice 3D model of what that looks like over time, 4D model. And so yeah, the data that the students are going to collect is going to be really informative, and it's going to really contribute towards the development of the entire process itself. So yeah, we're very excited about that, and we're also having a look at Bianca. I don't know if you want to weigh in here. Are you considering that maybe after our initial developments that maybe you add a few more sensors that could also be very interesting on a flight? I don't know if you want to weigh in here on that.
Yeah. So I mean, the first version we're going to do here, we have kind of like the same sensors we had in the XK07. So we have the IMU, we have the same kind of sensors that we had in the old system. What we have done in this one is that we added the camera. I think that, of course, because it's a camera, that gives a lot of opportunity, especially because it's a camera connector, which means that there's a number of different cameras available out there, you know, for, I was going to say, for any kind of price pockets that can be connected to the system here. And then there's a lot more that can be done with the camera. What we're going to do is that we're going to add more sensors, not necessarily all the sensors that's interesting in space. I mean, for example, we do have done a CO2 sensor, so volatile organic compounds and CO2. We are probably going to do like a microphone. We're going to do a particle matter sensor, similar to we had in an old system, just with this new format here. We're also planning to, the kit that we provide now have a soil moisture sensor, which is new. We didn't used to do that. Of course, that's a limited interest in space. Yeah, Tweety is holding one up. What we're doing is that we're working together with Quest, which is in California, and they have asked us to kind of like a system being the provider of technology to you're holding up the wrong chip, but we don't have the new one yet, huh? The one I had in presentation. Yeah, that's the right one for bluShift. But for Quest, we've been asked to assist them with different projects that can run on an International Space Station. So I think there's a suggestion of doing some kind of biological testing with a vial that can be scanned in space. So using either a light sensor, light intensity, or color sensor to kind of like monitor, or even the camera to monitor what's happening in a vial when it mixes in space. So something that microgravity is good for, or possible other stuff that could happen in space once we get into maybe low gravity orbital space. So a number of different sensors. What we're trying to do with the project here is also kind of like open the door a little bit with having some prototype board where people can come and say we want to do our own stuff. Fred Bruweiler, who's here, represents the American University, where they had done a muon detector that I think was meant to fly on ThinSat. Fred, I don't think you ever got the chance to get it to fly there, or if you did, you didn't get the data. But things like that, where we have different projects. Freaky, I saw you talked about some kind of fruit-based battery or nut-based battery that you want to test. And you know, the thing is that we have to kind of like have an open platform where you can say, well, how do I test that? Well, you maybe have like a DC converter that kind of like measures the battery's functionality in space and report on that. And what you want to do with a project like this thing here is test it out first in a low cost environment where you get it back before you maybe either send it to the ISS or put it into a proper satellite or whatever it is. So those kind of things is like, you know, where you have a setup where you don't have necessarily standard chips, but you build your own kind of like a board for checking out stuff. So yeah. Judy, did I miss any specific things you had in mind?
No, Bjarke, yeah, it was about the camera connector and the microphone. So yeah, that's okay, really going to be very interesting. Yeah, absolutely. So Seth, I think I'm not seeing any more questions.
No,
I think is that it? I think we've been going for almost 90 minutes. So yeah, you know, not even Judy can talk that much. Never knew the day would arrive. I have a question for. I have a question.
Judy, just hang
Sasha.
on. There's Jim has asked here. We have an inroad to globe.gov. You've been speaking to Globe. Maybe just talk about that for a second.
Yes, I have. We've been certainly introduced to Globe, and we have presented on their excuse the pun, global forum twice, and it was very, very, very close to the pandemic. We were actually scheduled to meet up with the team from NASA that supports Globe, and unfortunately then the lockdown happened, and I haven't been able to revive those meetings, but certainly there's a lot of interest from Globe, and also especially in terms of the work that we've been doing with the United Nations Development Programme and UNICEF, relating to the Sustainable Development Goals, with the students doing their projects and relating space and space observation data with how do we use that to tackle the Sustainable Development Goals, as well as in situ data collection. So yes, Bianca, that's great. Fred is saying we will have a session. Will we have a session dedicated to STEM student outreach? One discusses level of students' curriculum development, etc. Definitely, Fred. Yeah, let's take that up. We definitely need to have a look at what are we going to do in terms of promoting outreach. Bianca and I originally built this entire program around outreach, and being able to go to schools that did not have laboratories, that did not have facilities, etc., so they could literally build their electronics by hand. So I think we definitely need to have a component of that. Sasha is saying that he has to head out. That's absolutely fine.
Thank you very much, Judy. We're really excited about this.
Great.
And
that's great. Now we can talk about you, Sasha, but that's absolutely fantastic. It's all good. You have a business to build. So I'm going to field the question to Seth.
Okay.
Seth.
All right. Take care, guys.
Fantastic. Cheers, Sasha. Seth, when are you going to run another crowdsourcing campaign? We're desperate to find out about this.
So our equity crowdfunding campaign on WeFunder is in fact live again. And so the link is on our homepage. And on WeFunder, there's the terms of the raise. There's some really excellent information on safe note rounds and how exactly they work. Yeah, we're back live.
That is great, and and one of the reasons why I'm bringing it up is because there are 5 groups of students who are participating in this challenge, thanks to the generosity of some of your investors. If you want to just share with everybody how you've been able to do that.
Yeah, so one of the perks up until we hit our initially stated goal of 1.07 million, and we're going to keep going from there. But one of the perks is that at a certain level, the investor can nominate a school or educational program to get a FlatSat with MaxIQ that's going to fly aboard Starless Rogue's first flight.
Yes, absolutely. So that, yeah, as you say, that was a really nice perk, and also for us, what it is that it gives an opportunity for mere mortals like ourselves to be able to invest in a rocket startup company, in a launch company, and we would never have access to being able to invest like that in any other way. So it's a very innovative model. It's a very relevant and up-to-date type of funding model. So I really wanted you to express that. And when we talk about,
oh, sorry, just real quick, I believe it is the first raise of its kind ever. And we have noticed a couple other nano launchers that are, maybe they haven't flown commercial yet, but they are doing equity crowdfunding now. So we may have been the first past that post.
Yeah, absolutely. And I think it's very relevant for this kind of industry. So I really think that you've broken new ground here, and congratulations really sincerely on that.
Thank you.
And absolutely. And while we're on the topic of sponsored participation, what I will do is to everybody who is in the session this evening, today, what I'll do is that I will send through a link. What we have is we do have an online application form. If you feel that you have a group of students and you'd really like to participate in this challenge, but you're not able to raise the funding to do it, then please actually apply there, because we have been able to raise some funding for some sponsorships. So yeah, I'm certainly going to send out that link to everybody who's been in the session.
That's wonderful.
Perhaps something we can do, Judy, too, is just put together a quick list of just a bunch of resources that we talked about today. And then I'm sure you have the mailing list that you sent out today, and I can look at the participants on our end who joined through us, and we can kind of send everybody a little package of information for everything we talked about today. Cool.
Cody, that's fantastic. Yes, very good idea. Thank you for that. Cody, did you notice that Fred Bruvala congratulated you and complimented you on your bow tie?
Yes. See, I told you the bow tie is classy. It's respectable. I don't know what that guy was talking about. He told me I could only wear it that one time. I don't know.
No, you have to tell everybody.
Right?
You have to.
Yeah,
I'll
tell everyone the quick story. Yeah. My senior year for my last prom, I was getting my tuxedo fit and I was looking all nice, and the gentleman's like, "Oh, like you should wear a bow tie. It'll be the last chance you'll have in your life to wear a bow tie." And that pissed me off. So here I am, and I'm gonna wear a bow tie every time I have a chance now. So that's the quick story.
Yeah, so that's a story.
I don't like being told what I can and can't do. You know what I mean?
Absolutely. So thank you, everybody. What I'd like to do is to close. Seth, I'd like to hand back to you. Thank you, everybody, for joining us. And it's marvelous. And I'm so pleased we've been able to start this journey together.
Smooth. Yes, thank you, Judy, and thank you everyone for attending. And if you registered, you can come back and watch this video later, scrub through it, edit it, make us say funny things. No, please don't. But this resource will be here for you. So thank you so much. And if you have any questions on the bluShift side, on the delivery service, I mean, we won't send we won't send the X chips to you. We won't send you the kit, but then we'll send it. You know what I mean? Any questions about that? We're all over social, whatever platform you're on, we're probably there. And also there's a contact form on the website, and I'll see it. If I can't answer the question, I'll send it to Sasha and he'll answer it. And on the MaxIQ side, actually, Judy, what is the best way for folks with questions tomorrow to reach you?
Absolutely. It can be Judy with an I at maxiq.space, and also Cody at maxiq.space. I can see Cody's typing, so maybe you're putting it in there. Yeah, or otherwise, just even on our website, we do have some contact details on our website. Yeah, there we go. Also, Judy at maxiq.space or Cody at maxiq.space.
And also, I'd encourage people to check out our social media. It's fairly new, so we would appreciate any support, but I'll also be updating that a lot more recently as our program starts to take off here, and any updates or any further information that we feel like you guys should be in the loop for will definitely be posted on our Facebook, Twitter, Instagram. So it's at maxiq.space.
Thank you, Cody.
Just put my email in there too. All right. Thanks, everyone. We're going to end the webinar now, and
thank you.
Hope everyone's keeping safe and healthy. And maybe we'll see you at the kickoff seminar.
Thank you.
Thank you, everybody. Thank you.